Welcome back, everyone. Today we're going to be proving the sum of signs sum to product identity here. So first thing I notice here is that we have on the right side 2 sine a plus b over 2 and cosine a plus b over 2. So the first thing I'm going to do is I'm actually going to redefine this here, and we're going to let C be equal to A plus B over 2, and we're going to let D equal to A minus B over 2. Now I want to be able to write A and B in terms of C and D, right? And so if we rearrange this equation, we get that A plus B is equal to 2C. Therefore, A is equal to 2C minus B. If I do the same thing here, I get that A minus B is equal to 2D, and therefore A is equal to 2D plus B. Then if we add these equations together, right, if we add, let's call this equation 1, this equation 2, if we add these two equations together, we will end up with 2A is equal to 2C minus B plus 2D plus B. Then the plus B and minus B cancel each other out. And then if I divide both sides by 2, I get that A is equal to C plus D. Okay, now I'm going to do the same thing, except this time I want to solve both of them for B and then combine them because I would like to find out what B is in terms of C and D. So let's do the same thing there. If we go back to equation 1, we could rewrite equation 1. Actually, I'll say this is equation 3 then. So equation 3 is going to be equation 1 rewritten. B is equal to 2C minus A. And then 4 will just be a rewritten version of number 2, which is going to be that that B is equal to A minus 2D. And now I'm going to add up 3 and 4 together. So let's do that. Let's add up 3 plus 4. If we add up 3 and 4, I get that 2B is equal to 2C minus A plus A minus 2D. And then I'm just going to cancel out the minus A plus A and divide everything by 2. And we get that B is equal to C minus D. And there we have it. So in summary, the important takeaways here from doing this exercise are that A is equal to C plus D and B is equal to C minus D. Okay, the next thing we need to do is we need to recall the sign addition and subtraction identities. So sine A is equal to sine of C plus D, right? Because earlier we found out that A is equal to C plus D and that B is equal to C minus D, okay? So therefore, that's going to be sine C cos D plus cos C sine D. And then sine B is equal to sine of C minus D, which is equal to sine C cos D minus cos C sine D, like that. Then we need to add these two things together. And the reason why we know we should add these two equations together is because at the end of the day, what we want is we want sine A plus sine B is equal to some stuff, right? That's what we want. And so I'm going to add these sides together. I'm going to disregard this middle step when I add them together. And I'm just going to get that sine A plus sine B is equal to sine C cos D plus cos C sine D plus sine C cos D minus cos C sine D. Okay, next I'm going to cancel out this one here, cos C sine D, and also negative cos C sine D as well. So I'll cancel out those two. and then I'm going to combine these two here. If we have sine C cos D added to itself, then that is the same as 2 sine C cos D, and that's going to be equal to sine A plus sine B. Okay, so then to figure out the next step, what we need to do now is we need to go back to our original formula. So let's remind ourselves what the original formula was. The original formula was 2 sine A plus B over 2 cos A minus B over 2. And so therefore, this would be the perfect point for us to sub back in our original, right? Originally, we said C is equal to A plus B over 2, and D is equal to A minus B over 2. So if we just sub those things in, we get this formula, right? If we sub these things in, we get the right formula. So sine A plus sine B, therefore, is equal to 2 times sine of A plus B over 2, and then times cosine of A minus B over 2, right? Because here we're just subbing in. All we did here was we just subbed C equals A plus B over 2, which is how we defined it in the first place, and also that D is equal to A minus B over 2. So by subbing those back in, we end up with the final formula that we sought out to prove. All right, so here's the full thing. If you have any questions, feel free to leave those in the comment section, and we'll see you for the next one.